Morning, teacher.
Morning.
How are you?
Morning, teacher.
We're fine, thank you.
Good morning.
And you're ready for a new week of serious work. We'll still be continuing with the periodic table, and we are going to wind up that topic today. So we'll just go through group 7, the bit that was left behind, briefly talk about group 8, and then later on we'll have questions that we'll be responding to as sample questions as far as this topic is concerned, that is atomic structure as well as the periodic table. But before that, can I request one of you to pray for us as we continue? Akampurira, can you pray for us?
Let's humble ourselves and pray. Father, Lord, Jesus, thank you for this day. We thank the gift of life and all that done for us. Lord, we commit this lesson into your hands. Let us understand. Let us remember whatever they are going to teach us. Please bless the work of the hands of the teachers. And Lord, let us not be distracted by anything. And Lord, we pray that we may not get any disturbance of connection, Lord Father. This time I pray. Amen.
Amen.
Very much.
Amen.
So I said we'll be winding up the topic, and we were looking at the families in the periodic table. We looked at group 1, where we said we have the alkali metals. Then we talked about group 2 that has the alkaline earth metals. And we went to group 7 that has the halogens. And I think that's where we ended last week. I just want to have one of you reminding us what are the members in group 7. What are the members in group 7? Lukulobi, can you give us an answer?
Yes, you're asking for the halogens.
Yes.
Yes, we have fluorine, chlorine, bromine, and iodine.
Thank you very much. I hope all of us can still remember how we write the symbols of each of those elements. Can one of you remind us what is the valence of group 7 elements? What is the valence of group 7 elements? Oh, Paula? You can unmute yourself and give me an answer. Cousin Paula? Yes, please.
That she left her hand up. You can choose someone else.
Oh, okay. Jovia, can you give me the answer?
We have a valency of 1.
Thank you very much. Why do they have a valency of 1?
Because they receive 1 electron to make the outermost energy level full.
Okay, we said yes, thank you. Those elements have got 7 electrons in their outermost energy level. So they need 1 electron in order to become stable. So that is why their valency is 7. Can one of you remind us what the other properties of group 7 elements that we talked about? Other properties of group 7 elements? Okay. Michelle?
Group 7 elements are all nonmetals.
Thank you very much. They're all nonmetals. Denise? Denise? Denise, can you unmute yourself and give me an answer? Okay, can I have Rebecca giving me an answer? Faith Rebecca.
Their melting and boiling points increase with their increase in atomic number.
When the atomic number increases, the boiling point and melting points also increase. Thank you very much. Joan, do you want to give me another property of group 7 elements?
Yes, teacher, they exist as diatomic molecules.
The atomic molecules, remember we said when you're writing chlorine, you have to write Cl2, the molecule that exists. It has two.
What to say about you?
Okay, thank you. We'll be continuing.
Hello, Academy.
Now mute ourselves. We'll be continuing with the other properties of the halogens. We go down and we look at the other properties of the group 7 elements in terms of reactivity, reactions.
Teacher, can I give another property of halogens?
Yes, please.
They react with metals to form solid salts.
Okay, thank you very much. We react with metals to form solid salts. Okay. Mr. Arjun, I think we'll be looking at the next page. You can go ahead, I think not yet there. We have finished that bit, okay? Yes, chemical properties, thank you. So I hope we still remember the difference. Tangaza, do you have a question? I see your hand up or an answer. Okay.
Yeah, no, I had left my hand up, sorry.
Okay, thank you. So we'll talk about the chemical properties. And I remember saying that when you're looking at the chemical properties of a given substance, you're taking note, how does substance behave when reacted with other substances? So if we are looking at group 7, how do they react with other substances? Now, the first reaction that we have here is group 7 elements react with hydrogen to form halides. They burn in hydrogen to form hydrogen halides. Now, what halide is coming from, when we're looking at the radicals, we're looking at the, I have some people that have not muted themselves. Can we all make sure that we mute our microphones so we don't have a background information? Yes, thank you. Oh. So I said that when we're looking at formation of ions, we see that we gain electrons. That is someone whose microphone is on. I have a lot of feedback. Okay. So I said that when chlorine gains an electron, it becomes chloride. We no longer call it chlorine, but we call it a chloride. So generally, halogens, when they react with other substances, the name ceases to be halogen and they become halides. So in this case, we said we get the hydrogen halides. And the example that we have here is when chlorine reacts with hydrogen, we get hydrogen chloride. Is an example of the hydrogen halide that we are looking at here. Now, remember we said that at the start, you can practice writing the word equations. Chlorine plus hydrogen, we get hydrogen chloride gas. Now, you could have looked at the formula of some of these compounds. For example, the formula of hydrochloric acid is the same as the formula of hydrogen chloride. The difference between the two, when I say hydrogen chloride, for it is a, while hydrochloric acid is supposed to be either aqueous or a liquid, depending on whether it is concentrated.
Your pardon, you weren't clear.
I don't know why I'm getting feedback, but I said that look at one of the reactions here, chlorine reacting with hydrogen, and I said we get hydrogen chloride. And I said what we need to practice for now is writing the word equation. I said that we're looking at hydrogen chloride and chloric acid, the two have the same formula. All of them, we write them as HCl. Now, the difference is when we're talking about hydrogen chloride, it should be a gas, while hydrochloric acid is an acid which must be either aqueous if it is dilute, or we write liquid if it is concentrated. Now, for us to get hydrochloric acid, we see those hydrogen chloride in water, as we see in our notes. I don't know if the girls have a question for me as far as that's concerned. Okay, Mr. Arjuna, can we look at the next reaction? Okay. Now, the next reaction that we have there is chlorine reacts with water to form a mixture of acids. Now, young ladies, you don't have to be worried about the equations that we have here for now. I said when we move on, our topic will be looking at how do we write formula, how do we write the equations. But you still need to know how we write the word equation. So when chlorine gas is put in water, it will react. So chlorine gas is acidic. And when you put it in water, it forms two acids. We get hydrochloric acid, and the second acid is called hypochlorous acid. Hydrochloric acid and then hypochlorous acid. And we need to note that chlorine is a bleaching agent. Now, why do we say that chlorine is a bleaching agent? I'm hopeful that all of us have ever heard the word bleaching. Bleaching means you're removing color from a colored substance. I know we have used the jik, all of us. If your cloth is stained, you usually put in jik. And when you put it in jik, you want to remove that stain. And the active compound in jik is called hypochlorous acid, and it comes from chlorine when chlorine reacts with water. So
When chlorine reacts with water. Do you know the way to say water? Water.
Please mute your mic.
can we have the girls mute their microphones, all of them, please? Okay, thank you. So I have said when chlorine reacts with water, we get hydrochloric acid, and we also get hypochlorous acid. Then I said chlorine is a bleaching agent. And the reason why it is a bleaching agent, because it removes color from a given substance. Okay. We can look at number 3, Mr. Arjuna. And this is a reaction that someone already gave us, that halogens react with metals to form salts that we call halides. And most of these salts are usually solids. Now, the common example that we'll be talking about most times is chlorine. Remember, we said halogens are non-metals. So non-metals can be able to react with metals, and then we get compounds out of them. So in this case, when chlorine reacts with iron, we get a compound that we call iron 3 chloride. Now, I hope we remember where that 3 is coming from, or we didn't talk about that, I think. But we said that there are some elements that have more than one valence. Now, when they have more than one valence, usually when they're forming a compound, you need to specify what is the valence that has been used in this particular compound. So when we say iron 3, it is supposed to mean that iron is using a valency of 3 in this compound. Iron has got 2 valencies. It has a valency of 2 and a valency of 3. So you need to specify that when it is forming this compound, it is using this particular valency. Okay, so we've said when chlorine reacts with iron, we get iron 3 chloride. These are some of the reactions that we'll be looking at later, probably in senior 3, because we have a full topic, which is chlorine and its compounds. So we go into details to see how is iron 3 chloride formed? How is sodium chloride formed? That is something that we'll look at as we get to senior 3. But for now, you need to note that halogens react with metals to form salts that we call halides. So the next example that we have here is chlorine plus sodium, we get sodium chloride. I have said you need to emphasize, as for now, you should be in position to write a word equation. Chlorine plus sodium, you get sodium chloride. Maybe one of the girls can tell me if it was bromine reacting with sodium, what would be the name of that compound? Bromide plus sodium. Bromide plus sodium, what would be the name of the compound?
Sodium bromide.
Thank you very much. It would be sodium bromide. If it was iodine, can someone give me the name? Iodine plus sodium.
Sodium iodide.
Sodium iodide.
Okay, thank you very much. Those are the other examples of halides. Of course, we can't list all of them here, but we need to note that when they react with metals, we get the salts that we call halides. Some of those examples that we've listed there. Okay. The next reaction that we have here is reaction with sodium hydroxide.
Madam Silverine, you can pick up on question. You can pick a question from Karen.
Okay, please go ahead and ask your question.
Excuse me, teacher. I don't understand what these salts are like. Are they like normal salts? What do they do? Okay, what are the properties of the salts?
Okay, thank you very much for your question. Now, in chemistry, when we talk of the word young ladies, okay. When we talk of salt, in chemistry, it's a group of so many compounds. And the common salt, which is sodium chloride, is just an example. That is why we are looking at it here as one of the compounds formed. So you need to know that when we say salt in chemistry, it goes beyond the normal table salt that we have, but there are many other compounds that we call salts. Now, in simple terms, usually a salt is a compound formed when a metal reacts with an acid. Simplest, but you don't have to be worried. We have a topic ahead, which we call acids, bases, and salts. So we look at salts in detail, give their properties, look at how they are prepared, and so on. So I hope that answers your question, young lady.
Thank you.
Excuse me, teacher.
Yes, please.
I have a question.
Go ahead.
Teacher, when you, okay, that part of chlorine plus sodium, you get sodium chloride, right?
Yes, please.
And then chlorine plus iron, you get iron 3 chloride. Why that when we have sodium, when we have chlorine and sodium, why don't we say sodium 3 chloride in?
Thank you very much for your question. I don't know if one of the girls would want to respond to that question. Can I have anyone responding to her question? Yes, please.
You say that iron has a valency of 3. That's why it's iron 3 chloride.
Okay, thank you. Now, I said we put 2, we put 3, we put whatever number it is when an element has more than one valency. And I said iron has a valency of 2 and it has a valency of 3. Now, because it has 2 valencies, we need to specify that in this compound, it is using a valency of 3. That is why we called it iron 3 chloride. Now, when it comes to elements, for example, sodium has only 1 valence, and the valency of sodium is 1, if you remember when we were looking at valencies. So there is no need for us to mention that it is sodium 1 chloride because sodium has only 1 valence. So I hope that answers your question.
Yes, teacher, thank you.
Welcome. Any other questions from the girls?
Juliet and Lucinda.
Yeah, excuse me, teacher. So does that mean like the result of like elements that bond with different valencies, do we get like mixed oxides?
Do we get like mixed oxides?
Yes.
Can you repeat your question, the first bit of the question?
Like when you react elements with like differing valencies, do you like get mixed oxides?
Not really. It depends on the conditions for the reaction and what they are reacting with. For example, here you have not seen us mention that we get we get iron 2 chloride. We only get iron 3 chloride. So it depends on the conditions of the reactions and what they are reacting with if you are to get which product.
Thank you, teacher.
I have another question from any other person.
Excuse me, teacher.
Okay. Yes, go ahead.
Can I ask my question?
Yes, please go ahead.
Teacher, I'm confused. How does iron have 2 different valencies? Is it an isotope?
Now, if you remember Sample Mure when she looked at the periodic, And she showed us a complete periodic table having the transition elements. And one of the properties of transition elements is they have more than one valency. And iron is one of the examples of a transition elements. So because it is a transition element, that is why it has a valency of 2 and a valency of 3.
I still don't understand.
Okay, I don't exactly know why you are saying you don't understand. Can you probably phrase your question again and we get to know what your challenge is?
Okay, in the energy levels, valence is the number of electrons in the energy levels. So how does it have 2 and 3 electrons in the outer? How does it need 2 and still need 3 more electrons in the outer energy level to equal this?
Mr. Arjuna, do you want to respond to that question?
Like, I'm hoping that my network will not be bad. When we talk about valences, we say that these atoms have options. They have options of gaining, let's say, 5 electrons or losing 5 electrons. So in all these cases of atoms reacting, they always have an option of either gaining 1 or 2. They always have options, but they always take an option which is easy for them. But depending on the conditions, they end up taking 2 conditions or 1 at a time. For example, in this case of iron 3, iron is using a valence of 3 because it's combining chlorine gas or a halogen. Then you're going to realize that if iron with like hydrogen chloride, it will use a valency of 2 because all those options are possible. It can use 2, it can use 3. But in this case, they are varying because of the reactant. They are forming with only a halogen. If you remember in year 1, when you talk about oxygen, they also told you that when you're heating oxygen in air, when iron is burning with air or oxygen, it can use 2, it can use 3. Those options can be easy to happen. They can easily happen. That is why we form 2 oxide. We can also form iron 3 oxide. So it goes back to the valence, yes, valence electrons. Maybe something that I need you to note. It is not the number of electrons in the outermost shell. It is the number of electrons either gained or lost when an element is reacting. So it's not that iron have 2 or 3 in the outermost shell. No. Iron can gain, iron can lose 3, or iron can lose 2. Okay, Madam Silverine, you can go ahead.
May I also say something, Teacher Silverine?
Yes, please.
Yes, maybe to still answer her question. When we talk about, thank you, Mr. Juna, first of all, and Teacher Silverine. When we talked about the transition elements, we said that those transition elements, much as we mentioned them, their chemistry is beyond the level of senior 2. What you need to now know is to master their valencies, because at this level we don't draw the atomic structures of the transition elements. But what you should know is that iron has a valence of 2 and 3, copper has a valence of 1 and 2, manganese. So don't disturb your head going into why it is 2 and 3. For now, just master those valencies. When you get to senior 5, you will go into the details of the chemistry, why the valence is 2 or 3. But now just know that all transition elements have multiple valencies and learn those valencies. Thank you. I submit, Teacher Silvery.
Okay, thank you so much. I hope everybody has got some good information as far as that question is concerned. So we'll continue with properties, and the property that we're looking at before I mentioned that usually a salt is when a metal reacts with asking, but this reaction there is no acid. Yes, I understand there is no acid. I mentioned that some test cases it is a salt called I said we look at the details of what a salt is, the example of salts, and then their properties. So the next property that we are looking at here is reaction with sodium hydroxide, and we are dividing this into two. We are looking at them reacting with cold dilute alkalis and also reacting with concentrated alkalis. Now, the word alkali, we'll also be looking at it as we look at acids and bases later on. But sodium hydroxide is one of the examples of compounds that we call alkalides. Okay, so when chlorine is bubbled through a solution of sodium hydroxide, we expect to get two compounds here, or two salts like we said before. So the salt that we get is, or the salts that we get are, we get sodium chloride and we also get sodium hypochlorite. I said you don't need to be worried about these reactions because we repeat them later on when we study the details of chlorine and its compounds. And we probably go ahead into doing some experiments that we have not talked about here today. But you need to know that when chlorine is reacting with sodium hydroxide, the hydroxide is cold, we get two compounds that are salts. We get sodium hypochlorite, and we also get sodium chloride, but also water is given off as a product. Now, in this, we are looking at how conditions of a reaction determine the resultant products. If the alkali, which is sodium hydroxide, is cold and dilute, you expect those products to have. But when it is concentrated and hot, we also get other products, and we are calling them sodium chlorate. Some of us have heard about potassium chlorate. When we're looking at preparation of oxygen, we said one of the compounds that we can use is potassium chlorate. So it is in the same category as sodium chlorate. So you get sodium chlorate and sodium chloride, but also water is formed. So you need to note that when the alkali is hot and concentrated, you get a chlorate, but when the alkali is dilute and cold, you get a hypochlorite, which is sodium hypochlorite. I understand the equations are quite challenging for now, so you don't need to concentrate on them a lot for now, because we repeat this when we look at chlorine and its compounds. So I can look at the last reaction here, then we can get a few questions. Mr. Arjuna, reactivity of the group 7 elements.
Charity, you can ask a question.
Teacher, my question is
Your network is not clear.
So in order for elements to be in a particular group, first of all, they must have the same valency and they must have the same number of electrons in the outermost energy level. But for bromine and iodine, the one for bromine is 1. My question is that in order for one element to be,
I think you need to first hold on, then probably when your network is okay, you can ask. Get it? Okay, can I talk about the activity of group 7 elements? We said that when you look at the periodic table, the most reactive metals are in group 1. So in group 1, that is where we have lithium, sodium, and then potassium. And we say as you go down that group, that is group 1, you find that potassium is the most reactive, just as in reference to the reactivity phase. Group 8, group 7 of the heart, they become more reactive at the, sorry, they are more reactive at the top and they become less reactive as they go. So fluorine is the most reactive, followed by chlorine, bromine, and then iodine comes last. So iodine is the least reactive. Now, I can briefly talk about it, that as these non-metals react, they react by gaining electrons. And when they become bigger, that tendency to gain electrons becomes reduced. That is why chlorine, which is smaller, is the most reactive. It can easily receive electrons compared to iodine, which is bigger. So for the group 7 elements, as you go down, they become less reactive. Now, the reason this one came in, we want to look at the displacement reactions of group 7. We get one that is more reactive and we react to the salt of the less reactive. It is going to displace it. Just like we've been talking about, if I get zinc and I react it with copper 2 oxide, I displace copper because zinc is more reactive. In this case, if I get chlorine and I react it with the salt of bromine, for example, bromine, I expect chlorine to take up the place for bromine or bromine. So, I can look at the reaction. So in this case, we shall get potassium chloride, and then bromine will be given off as a gas. So why does this reaction take place? It takes place because chlorine is more reactive than bromine, and it displaces it from its salt. It is the same chemistry as we looked at reactivity series. I don't know if we get to remember that bit of reactivity. If you get a metal that is more reactive and react it with one that is less reactive, it is going to displace it. So even here, chlorine is more reactive than iodine. If I get chlorine plus potassium iodide, I expect chlorine to displace iodine. So I get potassium chloride, and then iodine is given off as the other product. I think I should receive questions.
Divine.
Divine.
Teacher, my question was about iron.
Destiny.
As it was answered.
Okay. Destiny.
Teacher, do halogens react with metals when heated?
Yes, please.
Do halogens only react with metals when heated?
Does hydrogen react with?
Do halogens react with metals when heated?
Yes, heating is one of the requirements for the reaction. The metal has to be heated, then you pass on the gas when it is dry, so that two will be able to react.
Thank you.
Welcome.
Okay, Shona, unmute yourself.
Yes, teacher, I have a number of questions. So the first one was that can these halogens form oxides if passed through oxygen, like acidic oxides?
They do, but that chemistry is at A level, not at B level.
Okay, and then also, is it true that like if you get a gas and a gas and like you combine them together, they form a liquid, or it's just a specific element?
For example,
Pardon?
It depends on which elements are reacting. It is not obvious because sometimes gases react with gases to form gases. Oh.
Okay, and then also that if you say like carbon dioxide, and is it the same as saying like carbon 2 oxide? Like, are they the same or it's different? Or how you
It's
say like
different. Now, carbon has also two valencies that it can use. It can use a valency of 4 and use a valency of 2. So in carbon dioxide, it uses a valency of 2, a valency of 4. So we can call it carbon 4 oxide instead of carbon dioxide.
okay, and then my last
that is carbon monoxide then.
okay, and then my last question is that could you explain more about dilute and concentrated? Because I don't really know what those two mean.
Okay, I say those reactions are a little bit complicated for now, but we'll repeat them later when we get to senior 3. But I said when chlorine reacts with sodium chloride that is dilute in cold, we'll get sodium hypochlorite. But when it reacts with hot and concentrated, we get sodium chlorate. Those are the different products. The other products are the same. In the two cases, you get sodium chloride and you get water. The only difference is at those 2 points. The cold one gives off sodium hypochlorite. Then the hot and concentrated gives sodium chlorate. The other products are the same.
Okay, thank you.
Okay, Mr. Juna, can we have the questions?
Michelle, unmute yourself.
As the chair, the girls also need to take note of a few properties of group 8 elements. Can one of the girls remind me the elements in group 8? Elements in group 8.
Can I answer?
Neon. Please.
Helium,
Neon,
and argon.
Argon. So we have helium, We have neon, helium, and then argon. Of course, there are others that are beyond our limit. What property do you remember about group 8 elements? Is there any specific property that you remember about group 8?
Yes.
Yes.
They don't react.
They don't react. Okay, we can say they are generally unreactive. Jovia, can you explain why we say they're unreactive?
They are unreactive because their outermost energy level is also the less than mean oil level.
Because they have a zero valence.
Okay, so Mr. Juma, can we have the questions? Yes, please.
Yes, Michelle, you can go ahead, followed by Peter.
Mr. June, I want you to share the questions that the girls should be answering.
My question isn't exactly about what we learned today. I was just wondering, in the test papers, I saw a question that said state the type of bonding, and I was wondering if we've done that or if we're going to do it.
That's our next topic, bonding. We'll be talking about bonding after this topic. Now, someone here is asking,
Shona.
Joseph, you're saying why is the electronic configuration of chlorine of bromine 2 to 8 to 8 to 7? I think we explained. Can all the girls mute their microphones?
You have questions from the girls. Can respond to them.
Okay, as they also look at questions that they have right now on the screen, so I want answers later on. Okay, can we have questions?
Berita, 2K, unmute yourself and ask.
Teacher, I didn't really get why the reactivity decreases when they go downwards.
Now, I think that for the non-metals, they react by gaining electrons. And if an element is to gain electrons, the ease with which it gains electrons, that makes it more reactive. If it doesn't easily gain electrons, that makes it less reactive. When the atoms are small, it is easier to gain the electron than when they are big. So as you go down the group, remember we said energy levels are being added. So iodine has more energy levels than fluorine. So fluorine will easily receive an electron compared to iodine. So that is why iodine is more reactive. That is why fluorine is more reactive than iodine.
Thank you, Madam Berita, followed by John.
I think it should be Joan.
Excuse me, teacher. When I looked in my textbook for the electronic configuration of bromine, I saw it's 2 to 8 to 18 to 7. How is that if the outermost energy level should, like the the maximum electrons on the outermost energy level should be 8. I thought it was
We said we are not looking at the configuration of bromine because it is above the first 20 elements. But the way you got it written, that is the right way it is written. But we are not looking at it because it is the 20 elements.
Okay, thank you, teacher.
Arinda, unmute yourself and ask. Then we can have Shona 2H. Unmute yourself and Arinda is not talking.
Yes, teacher, I was asking just to make sure that, like when we're writing the oxides for copper and lead, should we say copper 2 oxide or copper oxide? Which one is more accurate or correct? Or they are both the same?
Of course, we have not looked at that yet, but it should be copper 2 oxide because copper has more than that. Even lead, it should be lead 2 balance.
Thank you.
Johanna, unmute yourself and ask.
Teacher, I just wanted to clarify. When you get iron, is it like, are they two kinds, like iron 2 and iron 3, or is it that you buy it and it's the same iron and it just changes the valency depending on the reaction?
Yes, the element is one element. You find iron metal, but depending on the conditions that you expose it to, it can use a valence of 2 or it can use a valence of 3.
Okay.
Charity, unmute yourself and ask your question.
Teacher, I still have a question about halogens. So, teacher, in order for an element to be part of a particular group, they have to have the same valency and the same number of electrons in the outermost energy shell. But for bromine, in the energy, it is 1 and for iodine it is 3. So that means they have different valencies. But
now, I don't know where you got the valence of iodine as 3, but all of them have a valency of 1. Chlorine has a valence of 1. Chlorine has a valence of 1. All of them are. I hope you're not confusing iron and iron. Iodine has a valency of 1.
But teacher, the number of protons in iodine are 53. That makes it that the number of electrons in the outer energy shell is 3.
Now, I'm only wondering how you wrote the electronic configuration. Iodine is past the 20 elements. So we don't expect to write the electronic configuration, and probably the way you wrote it is not the way it should be written. But the outermost energy level should have 7 because it's in group. So while we gave you those atomic numbers, I don't expect you to write the electronic configuration of iodine.
I'm sorry, I left my hand up.
Okay, I
Okay.
hope the girls can
Iowa,
that question.
Precious, and Daphne. Okay, Madam Sylvan, you can go ahead. It's already 30 minutes past 11, so you can summarize.
I think we will just close at that point. We had that question. Probably the girls can look at and give me a few answers. Then we wind up at that question.
Send the questions to Google Class.
So can one of the girls give me the answer for part A?
2 to 82.
Show now.
2 to 8 to 3.
2 to 8?
8 to 3.
Thank you. Part B.
8 to 3. Period 3.
Part B.
3.
Period 3.
3. Group 3.
Group 3.
Then the period.
Period.
Period 3. Yeah, period. The third period.
Yes, conduct.
Yeah, it's
Yes.
third period. What's the currency of 3?
Currency of 3.
I'm saying the girls can have a good day.
Thank you, teacher. Send the questions to
Okay, girls.
teacher. Bye.
Thank you, Madam Sylvan.
Bye,
Girls,
teacher.
Teacher for teaching us.
this question will be
Bye.
new question.
Bye.
Teacher's making